Hi all. In this video, we are going to see a paper titled "A Deep Hierarchical Variational Autoencoder" from NVIDIA. This is a very simple paper. So this paper attempts to make efforts on improving variational autoencoder by a simple observation that the neural network architecture for variational autoencoder is more or less similar to the trend that we borrow from the supervised learning, like a classification task. But uh, the aim of output of the variation autoencoder, like unsupervised learning or generative modeling or supervised learning, is fundamentally have a different requirements. For instance, a generative modeling like a variation autoencoder try to make a hierarchical transformation from the input to a latent variable, so that there will be a very deep relationship between the input and the latent variable, so that information has to be written as much as possible while transforming from the input to the required latent variables. But in terms of classification work, when we are going for hierarchical depth-wise increasing the layers, we need to retain only the very relative informations for effective classifications. So this is something different requirements. So we this itself forces that we need to have an effective or different kind of architecture. The second one is over parameterizations helps in classification tasks, but here over parameterization, especially in the decoder side, will hurt the encoder setup, so that the essential informations during the training time will be missing, and more focus will be put up on the decoder side. And another thing is we need to have some kind of when we are increasing the number of steps for input to the latent variable of the output of the encoder, we need to have a long range correlations, which for which we need to have a very large receptions field. For that we need to have different architectures. And another important thing is during the training we need to have a very stable one for making an encoder and decoder network to correlate to each other to have a desired output. Most of the existing works try to omit batch normalization, which could potentially resultant in amplifying the instability. So in this one, we to make the variation to work great again, they make some hierarchical changes in the architectures by introducing a depth-wise convolutions, so that they can reduce dramatically the number of parameters, and also they make a long range correlations, and also they try to make some kind of regularizations to make training to be more stable. So these are some of the contributions from this model to make a novel architecture, and to by introducing the depth convolutions. And also they try to remove the memory burden, because depth convolution requires only a few number of parameters, try to overfitting the decoder part. And they also make a spectral regularization to make the training very effective and stable. Hopefully we'll come up with some other videos on some other papers on generative model. Thank you.